What is the biggest challenge during your tracker deployment that you face? Is it complex terrain, pile problems, maybe refusals or twisting or bending? Is it trying to reduce your labor costs, misalignment or deviations from the plan, or managing and planning for weather events like snow and hail? Curious to hear, what is your biggest challenge? And for someone who has faced a lot of in-field challenges, I'm sure Dustin's going to be curious to see what your answers are. Dustin, we talk a lot about how really it is true for trackers because, as Dustin mentioned, or as Dell mentioned in his interview with me, every tracker project is kind of bespoke. It's a one-off, and it's because the foundation is the piece that needs to be designed. We'd like to believe that we've been able to make it relatively cookie cutter, such that once the foundation and piles are in, that top of pile, the mechanical assembly goes smooth sailing. You get 100 people on the site and you just click through it, right? So if the foundation is right, then it seems the top of pile should be easy to align and assemble. Isn't that right, Dustin?
Well, CAD models obviously and on paper tell us that, right? But in the real world, in the construction industry, the installation of piles, there is human error, machine error, and what have you, as we have in the real world. Also ground conditions and soil conditions, as Dell had mentioned earlier. Pile type, whether it's C or maybe an H or W pile, we primarily use W piles. And then, all of these factors contribute to if your top of pile is within the tolerances, east-west, north, south, a settlement, right? And then a twist, one of the critical issues that can arise from pile deflection or just errors in installation. So, we actually, for that, TrinaTracker has designed our patented spherical bearing. And this spherical bearing allows for, roughly 30 degrees of full range of motion play. So very forgiving. And what this means is when you drive a pile into the ground and that top of pile is on the edge of a tolerance, or even we need to be within tolerance, but if we're on the edge of a tolerance, right, or we're on the outside of a tolerance, even our spherical bearing and the housing around that can compensate for that error in the field installation.
Yeah,
it happens all the time.
How's that been done traditionally, Dustin? I mean, how do you accommodate for a pile maybe being to the left or to the right, or too high or too low?
Well, it just depends. I mean, sometimes you may have to, maybe cut or drill the top of a pile. If the holes aren't aligned, well, at that point, if they're off, the holes are most likely not aligned. Maybe you have to cut or drill or fabricate something, or maybe even pull a pile and maybe redrive it in another area, right?
I can imagine that's cost effective.
Very cost prohibitive when you have to have when those actions happen, for sure.
Yeah, Dell mentioned in the past that there's a common design that's what you call jelly bean, that gives you some vertical and perhaps even some horizontal movement when you're attaching the collar, but there's not a wide range of acceptability or variability at the top of the pile, correct?
That's correct. Yeah, absolutely. Yeah. You can see over here. This is our a page of our white paper, as the audience is seeing here. So this is describing how our spherical bearing and components, the housing of the spherical bearing can, what kind of tolerances it can accommodate for, what kind of twist and lean and settlement we can accommodate for with the patented spherical bearing. So we've also been able to we've been able to really, reduce our install times with this spherical bearing up to 15% per tracker row. But, we see up to 50% decrease in install times per individual bearing.